Hi students, coming to the next topic in the subject operating system was disk scheduling algorithm. So here we are discussing about the disk. So different process wants to execute the operations, or if you different process wants to store the data in the disk and to retrieve the data on the disk. So suppose a multiple process came and the multiple IO requests are coming to the disk. So at that time the disk has to schedule, the operating system has to schedule which process has to take the first. So that explains about the disk scheduling algorithm. Okay, on the basis of priorities, on the basis of the some shortest time, and on the basis of the different operations based on the different conditions, the disk scheduling algorithm taking the IO request and sending the IO information to the IO devices. So this is about the disk scheduling. Means different algorithms, different techniques will be there to maintain the process to execute in a sequence order, means in the continuous form. So let us see the introduction part of this disk scheduling before going to explain discuss about the different algorithms that are present in disk scheduling. Now let us see the introduction part of the disk scheduling. So what is disk scheduling? The disk scheduling is done by operating system. Everything, disk scheduling means arranging the process in some particular time to execute the process at a particular time, means within that time. So which process has to come next, that you call it as a scheduling. Just like your timetable. So if your class is next which class and next which class has to come, so that is a timetable scheduling. In the same way, the disk is also allocated some scheduling. So this disk scheduling is done by operating system. So everything is done by the operating system, to schedule IO request. So whatever the IO request that the user is requesting, input output request, that arriving for disk. So disk scheduling is done by operating system to schedule IO request arriving for disk. It is also called as IO scheduling. Another name for disk scheduling is also called as IO scheduling. Why I am calling this as an IO scheduling? Because the IO input output is requesting the disk and to execute some operation, means to perform some action. So that's why the disk scheduling is also called as IO scheduling. So when multiple IO request arrives, the operating system has to choose an order to serve the request, means which IO request has to serve first, and that has to be scheduled, that has to be designed by the operating system itself. Serve the request. Now let us see different requests. Suppose this is a process A, reads tracks 2, 5. The process A wants to read the track 2, 5. And process B wants to read the track 3, 5. Okay. And another process came and it wants to read the tracks on the disk. Process C wants to read tracks 8, 4. Okay, now this everything, whatever the IO requests that are coming from peripherals or whatever it may be, so that request will be first sent to the operating system. The operating system has to read tracks and it is going to be scheduled. Operating system has to read tracks 2, 3, 4, 5 and 8, and that request will be placed on the disk. So this is how the disk scheduling will be done. The IO request that will be sent to the operating system. The operating system is going to schedule the requests that is received from the IO devices, and according to that process will be sent to the disk. Okay, there are many disk scheduling algorithms, but before discussing before discussing about the different scheduling algorithm, let us see some important terms that we came across in algorithm. So the first term that we let us see, the seek time. What do you mean by the seek time? Seek time means time required to move the disk arm to the required task. That you call it as a seek time. Seek time means the starting time, the time required to, the total time required to move the disk arm to the required task. Moving the arm to the required task, that you call it as a seek time. So let us take a disk. Okay, a disk consists of several tracks. Okay, so and within that you are having the sectors. Disk is here, I am taking as just, let us take the CD disk, so the compact disk. So a compact disk is in circular shape. So inside that you are having so many tracks. Okay, the circular is a track, and within the track you are having, this is a sector. Sector is used to store the information. In the sector the data is stored. Okay, track is just identification, means in which stage that data may be present. So here seek time means the time required. First, suppose the arm will be placed at any of the position. The arm that will be placed, the pin that placed on any of this position on the disk. Okay, so here the time required to move the disk arm. So this disk arm has to move to the required task. So the time that it takes to move to the required track, okay, and the track, some sector information is it, the time required to move this arm to that exact position, that time you call it as a seek time. Okay, means the first the arm has to reach the track on the disk, and from track it has to go to the sector. In the sector you will have the information, whatever the required information you need, that will be present. So the time it takes to move the arm to the required task, that you call it as a seek time. Okay, and next is rotational delay. What do you mean by rotational delay? Rotational delay means time required to rotate the disk to the required sector. Here we are rotating the disk to go to the required sector. So the total time that it takes to rotate the disk to the required sector, that you call it as a rotational. Means here we are talking about the rotations, and here we are talking about the time required to move the arm to the required position. So here the data is present. So to move the arm to that particular position, it takes some time. That time you call it as seek time. And rotational delay means time required to rotate the disk to the required sector. And the next one, data transfer time. What do you mean by this data transfer time? Time to read or write data from or to the disk. Data transfer means we want to transfer the data from IO device to the disk, or from disk to the IO devices. So the time to read the data or write the data from or to the disk means we are taking the data from disk and we are placing the data to the disk. The total time it takes to read the data or to write the data from or to the disk, you call it as a data transfer time. So by seeing this, if you know the seek time, rotational delay and the data transfer time, then the total access time to store the data or to retrieve the data is, therefore, the total access time for a particular sector, for a particular track, whatever the data we want to store, that the total access time to the disk is seek time. Seek time means time required to move the disk arm to the required task, plus rotational delay. It is a time required to rotate the disk to the required sector, plus data transfer time. It is the time taken to read or write data from or to the disk. So this is a formula for total access time. Seek time plus rotational delay plus data transfer time. So the main goal of disk scheduling algorithm is, what is the main, why we are using the disk scheduling algorithms? The main goal of disk scheduling algorithm is to minimize the seek time. The main thing is we have to minimize the seek time. For that cases, we are using the disk scheduling algorithm. So based on that requirement, the user requirement, we are using this different types of disk scheduling algorithms. Thank you.